Hello dear students, welcome to SciMa Academy. This is Prema here. I hope all of you are doing very well. If you have not watched my previous videos, please go and watch my videos and subscribe to my channel. Those who have watched my videos, they know that I am starting with the chapter Circles of CBSE Grade 9. So I have posted the last video on terms and definitions of the circles. You will get an idea of what are the parts of the circle. So now I'm going to start with the theorems of the circles. Before actually starting with the topic of circles or solving problems in circles, you must be very well versed with the theorems of the circles. Okay, so if you don't know the theorems, they are the very important properties related to circles. You will not be able to solve the questions in circle. Okay, so first we have to understand the theorem, how to prove those theorems, then we will start with some of the important questions of the circles. So let's get started. So today I'll be doing theorems of circles. Okay, before actually starting to learn circles, you have to first know the theorems of the circle. Okay, there are certain theorems or the properties of the circles which you have to be well aware of before you start solving the questions on circles. Okay, so because the questions are based on the theorems of the circle. So let's get started. So the first thing what you have to learn when we start the theorems of the circle is the angle subtended by a chord at a point. So students, I have told you what is the meaning of a chord. So if I draw a circle, so this is a circle if I draw. So this is the chord. Now what is chord? I have told you chord is a line segment which joins the 2 points on the circumference, right? This is the chord. So if what it says angle subtended by a chord at a point. Now this is a chord. It can subtend various types of angles. Okay, various angles it can subtend. So if I say this is, so if I consider this as the center O, okay, so this chord can subtend the angle with the center. Okay, this chord can subtend one more angle also here, and the chord can subtend one more angle even here also. Okay, so here what I am trying to show is here, see now the chord is subtending the angle with the center O. It is also subtending the angle here. See, this is what I told you. If you see my previous video, you will come to know this is the major arc. Okay, and this is the minor arc. This is minor arc. Okay, and this segment is the minor segment. Okay, and this is the major arc, and this segment, the chord is dividing this big segment. This is the big segment which is called as the major segment. Okay, so this is the major segment, this is the major arc. So the chord subtends 3 angles. Okay, here one angle is with the center, second angle you see here is with the major segment. Okay, and the third angle you see here is in the minor segment. Okay, so there are 3 angles. So let's name this. Okay, so if I name this as A, B, C and D. So here you see the chord subtends, the chord AC subtends what is angle? Angle AOC at the center. Okay, and angle ABC in the major segment, and it also subtends angle ADC in the minor segment. Okay, so you should be aware that the chord of the circle subtends 3 types of angles: angle at the center, angle at the major segment and angle at the minor segment. Okay, this property, this concept we will be using in the theorems coming up and also in the questions related to circles. Okay, So let's start with the first theorem of the circle, which is related to the angle subtended by the chord. Okay, so here the first theorem says that the equal chords of a circle subtend equal angles at the center. So if I make a circle, okay, if I make a circle and here I will make two chords, okay, so maybe a chord is here, another chord is here. Okay, now if this is the center of the circle, if consider this O is the center of the circle, so this chord is subtending an angle with this center, and this chord is also subtending an angle with the center. Okay, so you can see now the chord. Now let's name the chord. If you name the chord, we can name it as A, B, and this chord is C and D. So what this theorem says, that equal chords of a circle, that means AB and CD are the equal chords. It will subtend equal angles at the center. That means we have to prove that this angle AOB is equal to angle COD. That's what we need to prove. See children, these are the theorems which requires proving. Okay, so whatever theorem is given, we need to know also how to prove these theorems. Okay, that's what we are going to do now. So here, how do we prove? So it's very simple here. If you want the proof, so here we will take the congruency. Okay, so you have seen if you have seen my topics of triangles, how to prove congruency, you will understand. Okay, if you have not watched, please go and watch my triangle series. Okay, so here we will take the triangle AOB and triangle COD. Okay, so we will try to prove the congruency here. Okay, so here if you see in triangle AOB, OA we can write equal to OD because it is the radius of the circle, same circle, this is the radius, this is also the radius, right? Also we can write OB is equal to OC because again this is a radius, again OB is also a radius and OC is also a radius, right? And the third part, what we can write, AB is equal to CD because they have given equal chords are equal, so I can write chords are equal. Okay, so based on these three, so we have what? Side, we have side, also we have one more side. So therefore we can say triangle AOB is congruent to triangle COD. By which rule? By SSS rule, that is side 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 rule. Okay, so after that, once the congruency is proved, children, if you remember what is CPCT, that is corresponding parts of congruent triangles are equal. Okay, so once we have done the congruency of the two triangles, we can say angle AOB is equal to angle COD by CPCT. Okay, so this is how we can prove this theorem, that equal chords subtend equal angles at the center. Coming to the second theorem, which says if the angles subtended by the chords of a circle at the center are equal. So this is actually the converse. This is converse of theorem 1. Okay, so here I'll make a circle here. Okay, so if you see, this is the center. If you consider this as a center and we make two chords, so one chord is here, one more chord if I make, okay, and we join this. Okay, so let's name it. This is AB, this is center O, this is CD. So here what is given? Why this is a converse? Because here the angles subtended by the chords of a circle at the center are equal. So here what is given? The angle subtended by the chord AB and CD are equal. That is given to us, and then the chords are equal. We have to prove that the chords are equal. Okay, so here basically what is given here? Angle AOB is equal to angle COD, and we need to prove AB is equal to CD. If you see in the previous part, what was given here? It was given AB is equal to CD. Chords were given equal. What we need to prove here? We proved angle AOB is equal to angle COD. Okay, so this is just the opposite. Here it was chords were given equal. We had to prove the angle subtended by the chord equal. But here we need to, it's given other way around. Here the angle subtended by the chord with the center is given equal, and we have to prove chords to be equal. Okay, so here also we will do so here also we will do the congruency. Okay, so here also we will take the same triangle AOB and triangle COD. Okay, here again we can write OA is equal to OD because it is a radius of the same circle. This is radius and this is radius. We can write angle AOB is equal to angle COD because it is given. Okay, this angle is equal to this is given to us. And also we can write OB is equal to OC. Again it is the radius. Okay, this is again the radius of the same circle. So by this we have side, angle and side. Okay, therefore triangle AOB is congruent to triangle COD by SAS rule. Okay, so after that you can say that therefore AB is equal to, the chords are equal because they belong to the congruent triangles. So AB is equal to CD by CP CD. So it's very easy, children. So you have to first know what is the meaning of the angle subtended by the chord, the three angles which the chord forms. Okay, and then you can easily prove the theorem 1 and theorem 2. Okay, so hope you understood these two theorems. So if you found this video informative, if this helps you in understanding, do subscribe to my channel, and I'll be coming up with the next topic very soon. Till then, take care. Bye bye.